Hello, welcome to our review for test number 3. In this video, we're going to be going over the practice test that I've uploaded to D2L. I think there's about 14 questions, so we'll split this up into a two-part video, doing the first 7, part 1, and then the other 7 in part 2. All right, so let's get started. Notice it says you must show your work. Any work that's required to solve a problem, you need to show that in order to receive credit. Correct answers without supporting scratch work will not receive any credit. So you're going to have to show your work if you want to get credit. Number 1, find the exact value of each of the 6 trigonometric functions. Rationalize the denominator if needed. So notice it does say the exact value. That means no decimal approximations. And if I'm going to find all 6 trig ratios, I'm going to need all 3 sides of this triangle. So let's start by labeling opposite, adjacent, and hypotenuse. Of course, the side that is across from theta is always the opposite side. The side that is across from the 90-degree angle, that is always the hypotenuse. And the one left over must be the adjacent. So it would be a good idea to label those sides first, and then we're going to use Pythagorean theorem to find the adjacent. So we know opposite squared plus adjacent squared equals hypotenuse squared. 3 squared plus a squared equals 4 squared. And then it's just a matter of solving for a. So a squared is going to be whatever 16 minus 9 is. I believe that's 7. And taking the square root of both sides gives us the adjacent is square root of 7. Now then, now that we have all 3 sides, we can find the first 3 trig ratios: sine, cosine, and tangent. If you remember SOHCAHTOA, let me write that down real quick. SOHCAHTOA says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So opposite over hypotenuse would give me 3 over 4. Adjacent over hypotenuse, square root of 7 over 4. And opposite over adjacent for tangent, 3 over square root of 7. Now we're going to need to rationalize that. So if I copy and paste and then erase, I get my tangent rationalized. Now the first 3 are done. The other 3 are super easy: cosecant, secant, and cotangent. These are the reciprocal identity. So all I got to do is flip the sign to get cosecant. I got to flip the cosine to get secant. Whoops, and that's going to have to be rationalized. Copy and paste, and then erase. And if I flip right here for tangent, notice it's going to be rationalized already. So I actually want to write this down unrationalized so that I have something to flip for cotangent to get the rationalized answer. And we're done with the first problem. That is the 6 trigonometric functions for that triangle. Problem number 2, it says a tree casts a shadow of 26 meters when the angle of elevation of the sun is 24 degrees. Let's draw a picture. All right, so we have our sun, happy sun, and he's casting a sun ray. And then here's our tree. something like that. It says a tree casts the shadow of 26 meters when the angle of elevation is 24 degrees. So that's going to be this angle down here. And from here to here is the 26 meters. It says find the height of the tree to the nearest meter. So we're looking for the height of the tree. Now, I'm not going to label that H. I might get confused and think that's hypotenuse instead of height. What I do want to do is notice that the 24 is my theta, which makes the height of the tree the opposite side. And since the tree is perpendicular, this would be the hypotenuse. And that makes the 26 the adjacent side. So in order to find the height of the tree, which is the opposite, I'm going to have to figure out which trig function to use. And to do that, we're going to talk to the chief, Chief SOHCAHTOA. So you label the side you're looking for, label the side you know, then talk to the chief, and he'll tell you where to go. Isn't that an awesome rhyme? I'm going to say that again. Label the side you're looking for, label the side you know, that's O and A, then talk to the chief and he'll tell you where to go. That means that the chief is going to tell us that we need to use tangent of theta. And theta is 24. So tangent theta is O over A, opposite over adjacent. And then I can solve for the opposite side, which is really the height of the tree. So if it's okay with y'all, I'm going to label that H for height of the tree. Multiply both sides by 26, and we're going to have our height. Now, we will need a calculator for this. And we do need to be in the right mode. So please make sure that you're in the right mode when you're using a trig function. And it says round to the nearest meter, so that 5 is going to make the 11 become a 12. And so the height of this tree to the nearest meter is going to be 12 meters. And that's done for number 2. Number 3, solve the triangle. Round answers to the nearest hundred if necessary. So since they don't give me a picture, I'm going to draw a picture for reference. It's not necessary, but it doesn't hurt anything. It is a triangle. It doesn't say that it's a right triangle, so I'm just going to draw a generic triangle. And then I'm going to label what I'm given. A is 10 degrees. B is 60 degrees. And we know that little a is across from big A, so little a is 5, okay? Now, when it says solve the triangle, that means to find all of the missing pieces. So I'm going to label the pieces that I don't know, which is big C. I don't know angle C. I don't know little b or little c. And so I'm going to have to find all 3 of those pieces. And angle C is the easiest to find because all 3 angles have to add up to make 180. So angle C is going to be 180 minus the other 2 angles. So that's 180 minus 10 is 170, minus 60 is 110. So there's one piece of the puzzle down. And I'm going to go ahead and put that in that picture. And you can see that my picture is definitely not to scale. That doesn't matter, though. We just need it for reference. Now then, for little b, we're going to need to use the law of sines. And this is the way the law of sines starts. This is your blank template. And numbers that are across from each other go in the same fraction. So we can say sine of big A, sine A over A, sine B, big B is 60, little b we don't know. So this is how you set up your law of sines. We're looking for little b. I need to cross multiply. So that's going to be b times sine 10 equals 5 times sine 60. And if I divide both sides by sine 10, I'm going to have little b. This is a great time, again, to bring up your calculator. 5 sine 60 divided by sine 10. And does it say the word round? It says round to the nearest hundredth. That's 2 decimal places. So that'll be 24.94 rounded. And the units are not specified. So that's just going to be 24.94, whatever the units are. And lastly, for C, now we know little a and little b. We cannot use Pythagorean theorem because this is not a right triangle. And so we're going to have to set up the law of sines again. And let me just say, it's good to recycle. Now, what I mean by that, these numbers here, the 10 and the 5, I'm going to recycle them. I'm looking for little c, so I need big C. And then we're going to cross multiply and divide. C times sine of 10 equals 5 times sine 110. Divide by sine of 10. And we're going to have to button push that. All right, so I'm going to use my little back arrow here to make it a little bit easier. Sine of 110 divided by sine 10. And survey says 27, remember to the nearest hundredth, 06. 27.06, rounded. Okay. Now, notice I now have all 3 pieces of the triangle. I was given big A, big B, and little a. I knew those at the beginning. Now I have big C, little b, and little c. And I'm going to do a quick check just to make sure that these feel right. There's a quick check you can do just to make sure that you haven't screwed something up majorly. The smallest angle should have the smallest side. So angle A is the smallest angle. It does have the smallest side. And the largest angle should have the largest side, which it does. Little c is the largest of the 3 sides. Again, that's just a quick check. You can make sure you haven't made a huge mistake there. It won't verify that they're correct. It'll just catch any huge mistake. All right, number 3 is done. Number 4, solve the triangle or triangles, round answers to the nearest 10th this time. And again, we don't have a picture. So I'm going to show you that we can do this actually without a picture. As long as we're given an angle and the side across from it, that's the law of sines. So I can say sine 35 over 16.1 equals. Do you see how we set that up? The letters that match go in the same fraction. Big C, little c. And then in the other fraction for law of sines, since I'm given little a, I need big A. Big A, little a, big C, little c. And then this time we're looking for angle A. So we're going to do a little cross multiply. We've got 16.1 sine of A, 18.7 sine 35. I need to divide both sides by 16.1. And then what I'm going to do, since I'm looking for angle A, is I'm going to move the sign over so that I can isolate angle A. Now moving the sign over is going to make it inverse sine. And I'm going to have to use my calculator to calculate the fraction out to a decimal. 18.7 sine 35 divided by 16.1. And we're going to round that to, I know this says to the nearest tenth, but since this is an intermediate step, really it's best to go more places. That makes your answer more accurate. So it would be kind of funny here if I went to 3 places. That would be an evil number. I'm going to go 4 places. 0.6662. And then if I do the inverse sine of that, let's see, can I do it like this? Inverse sine of the previous answer. Cool. And that is going to be degrees. So that'll be 41.8 rounded. Where should I write that? 41.8 rounded. Let's note it up here. A is 41.8 degrees. Now, there's this thing called the ambiguous case. And what we need to do, since we're given only one angle to begin with, we need to check to see if this is the ambiguous case, which means that we would need to look for 2 sets of answers. Okay, so here's how you check for the ambiguous case. If you're given only one angle and that angle is acute, so that criteria is met. We're given only one angle and that angle is acute. The second criteria is that the opposite side has to be less than the other side. So what I mean by opposite side, I mean the side opposite of angle C, which would be little c. If that is less than the other side, then we need to look for 2 sets of answers. So this problem does meet the criteria for the ambiguous case, and that means that I need to look for a second angle A. Now, if there is a second angle A, it's going to be 180 minus the first angle A. All right, so let's see what that is. 180 minus 41.8. And that, as a decimal, is 138.2. 138.2. All right, so here's what we know now. We know A1, the first angle A, is 41.8. And if there is a second angle A, it's going to be 138.2. We know that angle B1 would have to make 180 with angle C and A1. 180 minus C minus A1. So this would be angle B1 minus 35 minus 41.8. And as a decimal, 103.2. So there's B1. Now, B2 would have to be 180 minus C minus A2, 138.2. If I do that calculation and I end up with a negative number or 0, that means that there would not be a second triangle. There would not be a second set of answers. But if this works out to be a positive number, then there are going to be two sets of answers. So let's see here. 180 minus 35 minus 138.2. Oh, and it's positive, so there are going to be two sets of answers. The second angle B is going to be 6.8. Now, what side was I missing? I was missing little b, and if there's two angle B's, there's going to be two little b. So let's make a note down here. B1 is, and we're going to have to use the law of sines to find that. Remember I said it's good to recycle. So the 35 and the 16.1, we're going to recycle that. We're looking for little b1, which means I need to use angle b1. And then we're going to cross multiply and divide. So b1 is going to be 16.1 sine of 103.2 divided by sine 35. And little b2 is going to be exactly the same calculation, except instead of angle b1, we're going to use angle b2. Do you see that's the only difference between calculating b1 and b2? And now it's time to button push both of those. All right, here we go. As a fraction, 16.1 sine of 103.2 over sine of 35. And little b1 is going to be 27.3. 27.3. And little b2. There we go. Little b2. If I simply go back, bump, and put in 6.8, I get my little b2, 3.3 rounded. Whew, man, that was a long one. Those ambiguous case problems are tricky, and you've got to know when to look for that. So before I move on to number 5, let me re-emphasize what it takes to meet the criteria for the ambiguous case. Are you listening? You have to be given only one angle, and that angle must be acute, and the side across from that angle has to be less than the other side given. If all of that criteria is met, then you must look for two sets of answers. And now we can move on to number 5. Two tracking stations are on the equator 115 miles apart. A weather balloon is located on a bearing of, okay, so let's draw a picture here. Let's call this tracking station A. This is tracking station B. And it says a weather balloon is located on a bearing of north 33 degrees east from the western station. That's going to be A, north 33 east. Okay, so how do we draw that? Well, from the north, it's going to fall over 33 degrees towards the east. And so here would be the weather balloon. 33 degrees. That's how you read bearing. From the north, 33 degrees towards the east. And then it's from the eastern station, it's on a bearing of north 13 degrees west. So again, from the north, and this one is northwest, which means this is going to go towards the west. How many degrees? 13 degrees west. What is the altitude of the weather balloon? Holy cow. Altitude. What do you want to call that? Height? Let's call that the height. Altitude is the height. So again, what you need to know here is you need to know how to read bearing. North 33 east. The 33 degrees is how much it falls over in that direction. North 13 west. Again, 13 degrees falling from the north in the western direction. And we're looking for the height of the weather balloon. All right, so let's just start finding stuff that we know. We know that that's perpendicular and that's perpendicular. So I can find this angle and this angle. They're complementary to the 33 and the 13 respectively. So what is 90 minus 33? Is that 57? Let's check that out. 7, 8, 9, 10, 5, 6, 7, 8. That's 57. And so 90 minus 13, would that be 77? 10, 7, 8, 9. There we go. Oh, and look at this. Now, if we call the weather balloon C, I can now get the angle at C, that entire angle, by doing 180 minus 57 minus 77. Okay? So C is 180 minus 57 minus 77. Gonna need a little calculator assistance. Let's bring him back over here. 180 minus 57 minus 77. 46. And so this angle up here is going to be 46 degrees. I'm not sure that I need to know that. I'm going to just find stuff that I know, okay? Oh, you know what? I forgot one thing. The two tracking stations are 115 miles apart. So from A to B, it's 115 miles. And that side is the side across from angle C. So I did need to know angle C. Okay, so what I'm going to do now is I'm either going to find little a or little b. I don't think it really matters which one you find, but we're going to have to find either little a or little b in order to get to where we can find the height. So using the law of sines, I know big C over little c has to equal, I tell you what, let's go with A. Has to equal big A over little a. And that will allow me to find side A. Doing a little cross multiply and divide, that's going to be 115 sine 57 divided by sine 46. And that's going to require button pushing. 115 sine of 57 over sine of 46. 103. And remember I said, since this is an intermediate step, we need to make that as accurate as we can. So let's go, how about to the nearest 4 decimal places? 134,0773 rounded. Intermediate step. All right, so now we know little a. So now what I want to do is grab a different color and have you focus on this triangle right here. This triangle. I know that this angle here is 90, right? That's a pun. And I know the side across from it, I know little a, and I know this angle is 77, and I'm looking for the side across from it. So that means I'm going to be able to use the law of sines again. Sine of 90 over A, 134.0773 equals sine of 77 over H. And then if I do a little cross multiply and divide, I'm going to be able to get my height. Okay, so the height is going to be 134.0773 sine of 77 divided by sine of 90, which I don't know if you know this, sine of 90 is 1. And so really I don't even need to put that in there to get the height. My calculator seems to always be covering up what I need to look at. All right, here we go. You know what? I'm going to put it in there just to show you. 134.0773 sine 77 divided by sine 90. And now we can round to the nearest tenth of a mile. So that's going to be 130.6 miles. And I'm going to put a big box around that. That is my final answer. And again, just to prove this, if I take the sine 90 out, same answer, because sine 90 is 1. Easy. Done. And I still have 2 more problems to do for this part of the video. So here we go. Solve the triangle. Round answers to the nearest tenth if necessary. Notice in this problem, I'm not given any angles. And so this means law of cosines. And it doesn't matter which angle you find, but I'm going to prefer finding the angles from biggest to smallest. That's what I call playing it safe. So since little c is the biggest side, that means angle C is the biggest angle. So for the law of cosines, we're going to start with cosine of C, and that formula says A squared plus B squared minus C squared all over 2 times A times B. So there I was saying the formula, and I was doing the plug and play as I go. And then what we need to do is we need to calculate this entire fraction out to a decimal. Bringing the cosine to the other side will make it inverse cosine. And now we just need the fraction calculated. 9 squared plus 13 squared minus 15 squared. All over the denominator. And as a decimal, okay, you know what? You can actually approximate that if you want to, but to keep this as accurate as possible, I'm going to work with that. 25 over 234. Since I leave that a fraction, that makes my answer as accurate as possible. I didn't round a decimal. And then if I do the inverse cosine of that answer, which I think I can do it like this, inverse cosine of the previous answer. And now I can round that to the nearest, what did they say? 10th. 83.9 rounded. 83.9 rounded. And there's one angle done and 2 more to go. And I'm going to continue to use the law of cosines, finding the angles from biggest to smallest. The next biggest angle would be angle B. And the formula for cosine of B, that's going to be A squared plus C squared minus B squared all over 2 times A times C. I hope you can see that there's a pattern there. And then we're going to need to calculate that. We're also going to need to bring the cosine over. Angle B is going to be the inverse cosine of whatever that works out to be. All right, 9 squared plus 15 squared minus 13 squared over. And again, I'm going to keep that to make it as accurate as possible. 137 over 270. And again, with the calculator, that's going to be super easy. I just need to do the inverse cosine of the previous answer. Round to the nearest tenth, 59.5. And now you know what I'm going to do, right? Instead of using the law of cosines again, I am going to use arithmetic. Angle A. All three angles have to add up to make 180. So angle A is going to be 180 minus angle C minus angle B. If you want to use the law of cosines, you can, but this is definitely going to be faster. Oop. Oop, I need that as a decimal. 36.6. And I hope you know 2 ways you can check this. There's 2 ways you can make sure that you haven't made some kind of serious mistake. First of all, you can add them all up, which they should all add to 180 since we use this arithmetic to get the last angle. That pretty much guarantees that they're going to add up to 180, but also the smallest side should have the smallest angle, and the biggest side should have the biggest angle, which it does. So that kind of helps catch any major mistake you might have made there. Now for the last problem for this part of the review. A famous golfer tees off on a long straight, 497-yard par 4. I'm pretty sure that has nothing to do with working the problem. And he slices his drive 14 degrees to the right. So the distance to the hole and how much he sliced it, those are both important. If the drive went 286 yards, how many yards will the second shot have to be to reach the hole? Round to the nearest yard. So it might help if we draw a picture here. So let's say from the tee box to the hole is 479. And remember, he sliced it 14 degrees. He sliced it to the right. And it says if the drive went 286 yards. So that's your distance there. What we're looking for is X. We want to know how long his second shot needs to be if he wants to put it in the cup. Now, I want to point out that this is a side angle side setup. We're given one angle and 2 adjacent sides. That's law of cosines. And this formula for the law of cosines, it says x squared, the side you're looking for, which is going to be the side across from the angle, is equal to 479 squared plus 286 squared. So you're going to square and add the 2 adjacent sides, and then you're going to subtract 2 times those sides multiplied times the cosine of the angle between them. That is the way the law of cosine sets up in this case for a side angle side. And then once we calculate all of this, which we can do all at one time, then we'll need to take the square root and get x. And luckily for us, our calculator, or at least if you have my calculator, it can handle that calculation all at one time. So we can do the square root of 479 squared plus 286 squared minus 2 times 479 times 286 times cosine of the angle between. And if I hit equals, that's actually going to give me the final answer because it's been square rooted. And it does say to round to the nearest yard. That's 213 yards. And there's problem number 7 done, and that's it for this part of the review. So if you have any questions or comments about anything that I've done, please leave them in the comment section below, or you can text me. And thanks for watching.